left some flyers, probably SSD here, sorry.
Yes, so go get some flyers. I'm the last one to close this session, I think, before questions. Do we have, I think we have a question right after this, right? Yeah. Sorry for me being a little confused. This is a long time since I've been to a scientific conference, and I've never been to a geosciences conference, and if you asked me 2 years ago whether I want to come here and talk to you, I'd probably have said no. My background is actually very, very different. I was a researcher a few years back. I did biomedical sciences. I decided academia is not the thing I want to be in. And I did something else. I went on to do campaigning and ended up working for 2 years, and that's one of the reason I'm here, with these people. Jens mentioned on his slide, on one of his slides, data is evidence. We had the motto, evidence is power. This was a project run by an international organization called Open Knowledge. And the project was the School of Data. And what we focused on is to help journalists, to help organizations, civil society organizations, and to help interested citizens to make sense of data. We wanted to give them data skills they could use to understand the world better. I was one of the people there, bringing a lot of the experience I had from doing campaigns, bringing a lot of the experience I had from using data in a research environment. And one of the things the School of Data runs is a fellowship. And luckily for me, I met 2 fellows there who were both into geosciences. So they were both GIS nerds. I think none of them are here, unfortunately. I would love to meet them. And they introduced me to things like how to do stuff with QGIS, how to deal with geodata. And with this, I also learned how to do this and sort of got a little bit more courageous when it comes to geodata and to coming and speak at a conference like this. But last September, I left them and I went to work for these guys, more exactly for these guys. This is the biggest online news outlet in Austria. I have switched my job from training journalists how to use data to actually be a journalist who uses data. Most of the stuff I deal with is questions like how do different election systems affect seat distribution of parliament, trying to explain things like the base rate fallacy to our readers. So why, if we have perfect surveillance, we will still catch a lot of innocent people. Look at stuff like how do migrations flows affect the European Union, etc. And a lot of stuff we produce are actually maps. And maps, and more maps, and more maps, and more maps. We actually do so, we produce at least one every week as part of a weekly series. And we look at different kinds of data we can get. We look at climate data, we look at data from agriculture, we look at stuff like the one on the top left is people who are missing or dead while trying to migrate, etc. And a lot of this stuff we actually try to get together from different sources, different research projects, different policy projects, etc., etc. And QGIS now once was a software that I didn't understand at all, and now has become one of the basic tools I use in my work to ask questions like, there were mergers of municipalities, and how do they fit together, etc. What I want to say with all of this is that whatever you do in your research, most likely is super interesting to people outside of research. Hans mentioned the carbon project, the carbon budget, sorry. This is one example of things that are super interesting for people outside. And for people like me who try to convey them to the general public or to a more wider public. There's two things I want to tell you I really, really need for doing my job and other people really need for doing their job. And the first thing is good metadata. We've mentioned metadata a few times. For those of you who are not familiar, I will quickly explain. And the second thing is something that has been touched over and over again, and this is licensing. So, what is metadata? For me, metadata is something very, very simple. It answers 5 basic questions. It answers the what, the when, the where, the who, and the how. It rarely ever mentions, has the last question, which is the why. And I think for researchers, the why is just a question that you should ask, right? Why are you interested in it? Because it's interesting, I want to know it. So what is the what, right? The what is stuff like titles, descriptions, but also stuff like column and attribute descriptions. Any of these published spreadsheets, without having a clear idea of what is in the column of a spreadsheet or in the attribute for this data object, is pretty much useless to anyone else who doesn't know this. And often you'll notice that the space, for example, inside a spreadsheet is very, very, very limited. Right? I can give a few characters, I can give a word, I can try to say something about it, but very, very rarely it's enough to make everyone understand what this thing is about. So having good descriptions about this is part of metadata, and it's a very important part of metadata. So I know if you say a population count, or if you say this and this measurement, I really understand what is this about. We did not talk about linked data today, because linked data is sort of a step ahead, which is sort of very, very strictly defining what kind of data is in there. The other thing that is necessary to have there is tell me expected values. Tell me what kind of value range I'm expecting in there. And what kind of values do signify certain things. For example, a measurement error or absent data. Right? Is absent data signified by there being a 0? I hope not. Is absent data signified by there being a negative value? Sometimes this happens. Or is it just blank? Right? Tell me how I should treat these kind of things. And if you use categorical data, so if you use categories in your data, it's very important for me to know how your categories are determined. I worked with datasets a while back where there were different categories, and they were actually conflicting in description. And I thought, how these two things actually describe, this one thing describes a subset of the other thing. How do they actually relate to each other? And it's very hard if you have no one to talk to and no one to contact to figure out what this means. Second question, the when. Right? We've heard about this. When was the data collected? Which time frame does it represent? And how long is it valid? Is this a process that's very fast, that's probably changed tomorrow? Is this a process that's very, very slow? That's probably valid a year, 2 years from now, and I can still use it. Is this something I should go and figure out whether there's new data, or is this something I can use and sort of represent some data that's collected in 2010, for example, and can still use it today to draw a conclusion? The where? Where was the data collected? What's the geographical scope? So is it an area I'm interested in? And also if you use geodata, right? If you use GIS data, if you use geolocation, tell me which projection, which coordinate reference system you're using. This is incredibly important, because without this information, all the geolocation in your data becomes guesswork, and I have to reproject and reproject it until I find one projection or one system that I think could be the one you used, because it looks like the points you collected are where they're supposed to be. So this is something very, very important. A lot of data formats, especially in GIS, actually have this built in. But if you publish data in a spreadsheet, if you publish data as a CSV file or as a text file, this is really important. And then the who. We talked about citation. There's another reason for having people on there. It's who can I contact if I have questions? For me, as a non-scientist or as a non-expert in sciences, it's very important to be able to call or email someone and ask, is the interpretation I have of this data, is this actually correct? Is the thing I try to say by using this data something I actually can say? Is there a different way? What are the things I have to be careful about? What are the caveats? What are the things I cannot say? And then finally, the how, and this all boils down to methods. Right? Document methods, and methods and methods. Tell me how it was collected. Tell me what I can say from it. Tell me all you can tell me about how this data set got together. And one very special part of metadata is actually licenses. And we are talking, we talked here a little bit about open science and we talked about open data. And we have not yet defined open data for you, for those who don't know. And this is actually part of the work of the Open Knowledge, where I worked with the School of Data. And one of the very first things they did, I think back in 2007, was they tried to define what they mean by saying open. And something, and especially data, is open when it can be freely used, modified, shared by anyone for any purpose. And this is something that's very, very fundamental. So if we talk about open data, if we talk about open science, we often think that the person using this is going to be a scientist or is going to be someone like me, but it could be anyone. And we also have to allow the possibility for them to build something entirely different on it, right? This is the any purpose. There is actually an amendment to this, which is that the only limitation you're allowed to make is the one that they are required to cite you originally. And how this is traditionally done is through using different licenses to grant permissions to whoever is interested in using the data. So by default, if you publish something, this is the case in the European Union, this is the case in North America, this is the case most of the world. Per default, your data and your publication is copyrighted. Right? If you live in the European Union, this is a right you cannot give away. It's actually slightly different in North America where you can give this right away. But this is a right that's very, very restrictive. This is a right that just allows people to explicitly grant the information or grant the permission to republish or to reuse whatever you do. For some kinds of data and for some kinds of communities, especially in the research community, this is actually handled slightly differently, right? The research community is very permissive in what I'm allowed to do with stuff that's published in a paper. For example, I can take it out, I can take the paper, reprint it, and distribute it in my class. I could take pictures, I can take graphs out of the paper to represent it, etc. But still, the underlying license most often is a copyright if you don't specify otherwise. The other case is if I'm dead long enough, or the author is dead long enough, or if I declare so and live in a country where this is permissible, is the public domain. So this is where no rights or where no limitations are in the data anymore. Think of old books, right? Works by old authors, long dead. You can just use them, and you can use them for anything. So if you want to use Moby Dick and do your text analysis, go ahead and use it, right? It's there. But to solve this, there's this body of licenses called the Creative Commons licenses. And they have a very, very wide set of licenses that actually allow you to classify your work and explicitly grant permissions to anyone you want to. And the very easy, or the simplest one is the Creative Commons Zero license. And the Creative Commons Zero license is basically an equivalent to the public domain. It says you can do with it whatever you want. There's no restriction, there's nothing on it. The next step up is something that's quite important if you want to be recognized for your work. This is the CC BY licensing, an attribution license. A license that says you're allowed to do with this whatever you want as long as you cite me as the original creator, as long as you cite me as the original source for this. So take my data, do whatever you want, cite me as the original source. This goes on, sorry, wrong direction, with another restriction which says use this and share whatever you created with a similar license, etc. But be aware, not all the Creative Commons licenses are open licenses. There's two editions that are very closed. There's the non-commercial and the non-derivatives license, which basically say you're not allowed to use this for commercial purposes, and you're not allowed to change anything in what you found, and you're just allowed to republish the original version of it. Which basically prevents me, if you're a scientist, it prevents you from using this data set in your own science and building something new. There's other open licenses like the ODBL, most commonly known for being used by OpenStreetMap. There's a lot of institutions that create their own licenses. A lot of governments do so. I wouldn't do this if I'm not a lawyer. But with this, I want to stop because I think I'm running out of time. And thank you very much. I'm around here. Come and chat. These are my contacts, so come and talk to me. Thanks.